Boom. So absolute value equations. All right. So you guys know what absolute values are. Is that correct? So absolute value. So for example, if I had the absolute value of 3, that would equal to 3. But so is the absolute value of -3. That will also equal to 3 because the absolute value just means the distance from 0. Okay, the distance from 0. So 3 is 3 away from 0. -3 is also 3 away from 0, right? So if I was to give you a problem, for example, absolute value of x, and tell you that that is equal to 3, what I'm showing here is that this x could be 2 different results. Make sense? So anytime I have this, I have to make sure that I write 2 different equations, that the inside x is equal to that 3, but that x is also equal to the -3. But notice that I wrote down the inside is equal to the positive of that side and also the negative of the other side. Okay? And also notice that that absolute value on the left side is all by itself, just like we did with the radicals, just like we did with square problems or any other type of problem. Make sense? Okay. So let's say, for example, I'm given something like this. I know this is a very easy example, but at least as an example. Wow. Okay. I guess I'll go with a rectangle. All right. So let's say the example says the absolute value of 1 minus 2x plus 6 is equal to 9. So the first thing I got to do is to get the absolute value by itself. And then set up your 2 equations, right? So in other words, my inside here has to equal to the 3, and that inside has to equal to -3. And then I solve. So just like quadratics, I'll have something like that. Questions? Good. Yes.
Why is the three the one that is talking
Because we proved up here that the absolute value of positive 3 is 3, and the absolute value of negative 3 is also 3. The 3. You're absolutely right. You're absolutely right. So think about this. How about we put it this way? Let's go ahead and replace this with, what was it, -1? Right? So what's -2 times -1? Positive 2. So 1 plus 2 is 3. Absolute value of 3 is 3, right? Plus 6 would be that. All right. So let's go ahead and take this out and replace it with, what was the other one? 2. Okay. So -2 times 2 is -4. 1 minus 4 is -3, right? Absolute value of -3 is back to 3 again. So it's always saying what happens on the inside has to equal to the positive of the other side and the negative of the other side. Does that make sense? It won't be worded. It's going to be just literally be given like this example right here. So it's just gonna, the problem would look something like this. Just like if it was a square root problem. Yeah, it would just be solve for x. But what you're looking for is these absolute value signs. Right? So if you just see two vertical lines that are next to it, you're like, okay, these are absolute values. So I gotta get this thing by itself, and then consider we get something by itself and then we do the opposite operation. For this, it's like, okay, we got this. There's really no opposite operation. So the only thing we can do is say, okay, what can the inside be? The inside could be the positive of the other side or the negative of the other side. That's it. And then solve for those answers. Now, can I have this? Can that happen? No. Because when I take the absolute value of something, it's going to be a positive number. Because it's just a distance, right? So since distance can be negative, right? Similarly, if I had this is no solution, right? Or no solution. Right? Because I can't take a square root of a number and get a -3. Right? Unless it's imaginary. But again, that was cute when you were 5. You're adults now. Grump. Now here's my next question. I should be able to write the square root of x. Actually, let's say square root of x cubed as a rational exponent. What would it be? What would it be? Unless the question is rewind, what the heck is a rational exponent, which is fine too. So rational exponent means a power, right? Rational just means a fraction. So a power that is a fraction. So how do I write that radical or the square root of x to the third as a fraction power? What if there's no index? What do we assume it to be? right? For the ones that don't remember this, or I should say, for my past students that don't remember this, you should remember this. I hope for the student that had me remembers this picture. And for the ones that never had me going, what is this picture about? Why would the sun and the tree and grass remind them of rational exponents? Funny you say that. Because over here, that fraction sign is the grass. What grows under the grass? Dirt doesn't grow, guys. Roots do, right? So roots grow under the grass. Over here, what's my root? Which is also my index, isn't that right? What do I get from the sun that's above the grass? I get power, right? That's how we get solar power, right? So 3 gives us power, or the sun should give us power, not the 3. So if that's the case, since that's the power, what is the power in here? The 3. That's the reason why the sun and the tree and the grass actually teaches us about rational exponents. Okay. However, that's all cute and all. What if we have, you know what? Just for poops and laughs, let's make up an equation. Let's say, for example, we have x to the 3/2 plus gosh, no, that won't work. So look, no, that won't work. Yeah, chat, no. Bayat. Say lo say. But yeah. How do I solve something like this? Same thing, right? Get this funny looking thing all by itself. Right? Let's isolate that funny looking thing. And then what? Perform an opposite operation, right? Just like if it was a square root, we perform an opposite operation. What is the opposite operation of this thing right here? Is it 3/2? So opposite operation here is the reciprocal. And the reason why it's a reciprocal is because when I raise the power to a power, which is the exponent rule, right? When I raise the power to a power, I have to multiply powers. Is that right? What's 3/2 times 2/3? 1. So over here, I will have x to the first power, which is just x. What is 8 raised to the 2/3? You can do this by hand or you can do this in a calculator. And then, so she's saying square the 8, which is 64, and then do what? I want to punch you in the face. Square the 8, because remember, the top is the power, right? Power means I square it. So square the 8, 64. What is the 3 coming? It's the cube root of 64, which is what? 4, C. So let me write this out. So what we're saying is that this is the right? That's what we're doing. That's what we got. Does that make sense? Ooh, there was an example I wanted to do though. Where's that example? Where's that example? Where's that example? Oh, don't tell me I didn't bring it. I really like that example. Oh. I don't see the example. I think the example was something like this. There was like 2 rational exponents there. Right? Then what do we do? So here's my question, right? If I had 2 radicals, what should I do? Right? Remember what the steps were, right? What was step 1 about radical equations? What was the first step? Get a radical by itself, right? If there's multiple radicals, I want to get one of them by itself so I can get rid of that radical, right? It might, at least it cancel out 1 radical, so I might only have 1 radical left. Then I got to do that process all over again to get rid of the second radical, okay? Over here with this, with the rational exponents, what we did was we kind of did the same thing, right? We isolate that funny looking thing. And then we did the opposite operation. Well, if I have multiples, I will want to get one of them by itself first, right? So I can get rid of this rational exponent and then try to get rid of the next rational exponent. Make sense? Don't try to get rid of all. I mean, if there's a possible way of getting rid of all of them at the same time, awesome. Chances are slim to none on that one. So just get one done and then go to the next one. Any questions on that? Nada? Okay. Let's get to 1.7.